So, today we will continue our discussion to divergence and curl. In the last lecture, we saw that what is gradient and what is its physical significance. And we also saw that del is a vector operator and it has all the properties of a normal vector. So, we always say that del will operate upon a function irrespective whether the given function is a scalar field or a vector field. Okay. So, in divergence, we saw that divergence results from the dot product of del with a given vector field. We know that dot and cross product are types of vector multiplication where both the quantities, both the physical quantities should be vector. Okay. So, we say that if I have a vector quantity v, then divergence of v can be written as, or we write it as del dot v. Okay. So, as it is the dot product of, it is resulting from the dot product. So, what does actually it means? So, when I have a dot product, say I have a dot b, then in its abstract form I write this as mod of a mod of b cos theta. Okay. And this equation tells me, you say that at theta is equal to 0, a dot b would be maximum. You say this, okay, we all know this. But what is the meaning? That is how much these two vectors go together. What is the change in the direction of, or in the parallel direction? So, always whenever we are computing dot product, it is going to give us magnitude in the direction parallel to each other if my dot product is maximum. Similarly, here for divergence, because I know I, j, k, del is represented as del by del x I, del by del y j and del by del z k. So, it means this dot product is going to give me the magnitude of rate of change of a given vector v, okay, along x, y and z direction. So, it should be along the direction of motion. So, if suppose I take example v and I say that this vector v is equal to 1 by 2 x I, this is v and this is equal to 1 by 2 x I, and if I define divergence, then I can say that divergence of v should be equal to del v by del x plus del v by del y plus del v by del z. Okay. Divergence is a scalar quantity. So, if first I will try to plot this vector field, I will plot this vector field and then I will see what actually this equation means. So, if I plot this vector field, see this is varying only in x, okay, there is no y dependence. So, when my x is equal to 1, when my x is equal to 1, the value of the v component is half, okay. When it is 2, it is 1, and when it is 3, it is 3 by 2. When it is 4, it is 2. So, it means when I have 1 here, okay, so here I will plot it is half, okay. When I have 1, then it is double the length, okay. When I move ahead, it is like this, and if I move further, then it goes like this. So, this is the vector field representation of this given function. And if I move along the y axis, there will be no change in the magnitude of these points, because my given vector field is independent of y, there is no y component. So, I can draw it like this. So, this will go on like this, okay, over the entire space. Now if I calculate the divergence, what would be the value? Divergence from here, del dot V is equal to 1 by 2. So it is constant, 1 by 2 is constant, plus another point here is it is a positive value, it is not a negative value. Okay. So here we will note down that it is constant positive. So what do I mean? If I draw what these vectors are, what these lines are signifying, they are signifying the velocity for a particular value of x. This is the velocity. I said that this is a velocity of a fluid. Okay. So it is giving me the velocity at different points on the x axis. If I draw an arbitrarily small circle, say here, if I draw an arbitrarily small circle here or a small surface, okay, if say it is a permeable surface, then you will see that amount of liquid entering in is less than the amount of liquid coming out, because this velocity is more. So per second volume of liquid coming out is more. Okay. So if this is the case, then we will get positive divergence. Okay. It means this point is a source. This is a source. I draw a circle, arbitrary circle here. Again, the same argument holds true. The amount of liquid entering into this surface is less than the amount of liquid that is coming out of this surface. Okay. So this is the positive divergence. Okay. So let us take this example little forward. This was a very simple example. Okay. So we would not always encounter such simple examples, but this was to give you that what exactly divergence is. Okay. And generally from a point source, what we see that positive divergence, if I have this point, then positive divergence is like this. Okay. So positive divergence should look like this. This is positive divergence. Point is a source. Vector fields are coming or emanating from a point. On the other hand, if the arrows were other way around, flipped by 180 degrees, then it would have been a vector field looking like this. And this signifies negative divergence, because if I draw an arbitrary circle here, then I see that lot of vector fields are going in, but nothing is coming out. Okay. So this will signify a negative divergence, and this would signify a positive divergence. Okay. Because if I see here, all of them are coming out. Nothing is going in, but everything is coming out. So that definitely the point should be a source. But here everything is going in and nothing is coming out. So it means the point should be a sink. Either it can be a source of charge carrier. Okay. So if I have a positive and a negative charge, then I will have going like this. Right? It will go like this. जो आप लोग पॉजिटिव और नेगेटिव चार्ज का जो इलेक्ट्रिक फील्ड डायग्राम बनाते हैं, it looks like this, it goes like this. So it means positive charge will have a positive divergence, whereas a negative charge will have a negative divergence. Okay. So this is one example. Let us take little more complex example. So whenever we are taking divergence, one thing more I would like to tell you, that divergence of V is actually the partial derivative of this vector field V in the x, y, z direction. So, whenever I take derivative, it is rate of change of a given quantity with some other physical parameter. It could be position coordinate, time or whatever. Okay. So, but in divergence I have del v by del x, del v by del z, del v by del y plus del v by del z. So, this equation tells me that what is the change along the direction of motion. So, always divergence will give the rate of change, always divergence will give the rate of change along the direction of motion. In this case it is fluid. So, along the direction of the motion of fluid or along the direction of velocity, what is the rate of change? So, whenever we are calculating divergence, we are seeing or we are observing the change along the given vector quantity. Whatever its direction is, we are looking for change along the direction of a given physical vector parameter. Okay. So, this is divergence. So, now let us take another example, and that example goes like this. If I have a vector field given by V is equal to say x square minus 3y plus 2I plus y square minus 3x plus 5j. Okay. So, what would be the divergence? It does not have any k vector, anything along the k vector. So, I will differentiate these two terms with respect to x and y. Okay. So, let us have, to make it little simpler, to understand it better, let us have only y coordinates here. Okay. X and y's. So, what I get here? I get this is 2x minus 3 plus 2y minus 3. This is divergence of V. Is it okay? This is divergence of V. So, in divergence of V, this divergence of V when it would be 0. Okay. Now, I do not know whether it is a positive quantity or a negative quantity. I do not know actually. So, it will depend upon the value of x and y. Okay. So, you will have to calculate the value of x and y, but one thing I can ensure, that if I have a surface, then I can draw a line along which always divergence would be 0. Always along that line divergence would be 0, and that line would be, if I put this divergence equal to 0, if I make it 0, then I will get that 0 is equal to x 2x plus 2y minus 6 is equal to 0. Okay. So, from here I get that x plus y is equal to 3. X plus y is equal to 3, and I get that y is equal to 3 minus x. So, this is the line along which divergence will always be 0 for this vector field. Okay. So, if you are not able to find out where divergence, how the divergence could be, but this you know that this is the divergence for this vector field, then you can always find out a line, you can always draw a line on the surface along which divergence will always be 0. Okay. So, we learnt few things in divergence, that in divergence we always look for change along the direction of motion. Okay. And we see that in divergence, if divergence is positive, then that point should be a source, and if divergence is negative, then that point should be a sink. Okay. Now, we have this is a very straightforward equation, del V by del x, del V by del y, del by del z of V. Okay. And we have calculated xyz equivalent in spherical and cylindrical coordinates. Okay. So, what you can do, you can try to find out divergence V in spherical and cylindrical coordinates. Okay. You try to do this. If you are not able to do it, then we will do it again, okay, in the next lecture. But now I will give you what curl is. Curl, we know, we all say that curl is basically rotation, okay. So, what actually rotation means? Again, curl is vector multiplication by cross product. So, if I have curl and if I have a vector field V, then for this curl is curl of V, or it is written as del cross V. In the Cartesian system, we generally calculate this curl by writing a determinant, and that determinant goes like this: I, j, k, and del by del x, del by del y, del by del z, and then I have Vx, Vy, Vz, okay. And here when I will calculate the determinant, I will not multiply this quantity del by del x with Vy, but I would operate this quantity on Vy, okay. There is a difference. So, you will be operating always whenever you are calculating curl, and you all have done this. There is nothing new in this. So, now again let us understand what exactly this cross product will do to a vector, okay. So, if suppose I have a vector field, say velocity, given by V is equal to y square I, okay, V is equal to y square I. So, if I plot this velocity, if I plot this vector field which happens to be a velocity field, then what I would get? For y is equal to 1, I get V is equal to 1, okay. So, I have this here. Now, you see along this line, the magnitude of this vector field is going to be the same because y is not changing. So, I can draw like this. But when I go to y is equal to 2, it becomes 4, okay. So, I have vector field which looks like this, and I go, then it becomes like this. Now, I have a question, whether you say that curl gives me the rotation of vector field. So, will this field have rotation or not? This field I have drawn here. So, will this field have curl? It will have 0 curl or non-zero curl? Just by looking at this diagram, can you tell me something? There is curl, this field is rotational or irrotational? बताइए, ये draw कर दिया. This is y, this is x. So, this x axis we can extend like this. Now, you tell me. Okay, if there is confusion, let us try to put a small twig. एक लकड़ी का टुकड़ा, पानी है, पानी बह रहा है, ठीक है. हम यहाँ पे we will put one small twig. Okay. If I put this twig here, what would happen? The flow of water here will push it forward, and the flow of water here will also push it forward. Okay. So, it means, but here the magnitude is less and here magnitude is more. So, it means this will be pushed like this. Okay. So, after some time it would be like this. So, it means there is a net torque acting on this, that is why it is rotating. It is not moving, it is not getting displaced, but it is rotating. So there is a net torque acting on this twig. So it means although all these vector field look very straight, but there is a rotation in the vector field. Okay. So this vector field is a non-zero vector field. This vector field will have non-zero curl, and remember, whenever I compute del cross V, the resulting vector by rule should be perpendicular to these two vectors. So whenever we calculate curl, we see change perpendicular to the given direction, given vectors. Whenever in divergence, we see change along the direction of the given vectors, whereas in curl we see rate of change of a given vector field perpendicular to the direction of the given vector field. Okay. Curl mein we always see change in the perpendicular direction, in divergence we see change along the direction of a given, along the direction of motion if the field is a velocity field. Okay. So it means this has got a non-zero curl. Okay. If I draw this again, say I redraw it just to understand it better, say the vector field goes like this, then it decreases, it becomes very small, and then it changes its direction. Now if I put a twig here, you will see that this vector will push this twig towards this direction. Okay. So the direction is like this, but this twig will push it like this. So a whirlpool will be formed. There is a net torque, you can clearly see. So a whirlpool will be here. Okay. So although these fields are straight, they are looking straight, but they have a very prominent curl along the direction perpendicular to themselves. Okay. So curl is basically rotation. The rotation magnitude, or it is the measure of rotation that a particular given vector quantity can produce. Okay. So now let us take some example. If say I have a vector given as minus yi plus xj, this is the vector, given vector, and you have to compute the del cross V. Okay. So from here I can write that this is equal to I, and I have del by del y, del by del z, vy, vz minus j. It goes like this, plus minus plus. Okay. And here what I would have, del by del x, del by del z, vx, vz plus k, del by del x, del by del y, vx, vy. So can you please tell me what from this expansion, what would be the value of curl V? बताइए what's the value that you get? 0. Are you sure? बताइए. Definitely you don't have to calculate these two terms, you just can go straight to this. Okay, you can go straight to this and then you tell me what is the value. जल्दी से बताइए. 0 या 2? I2, सबकी 2 आ गई. So this is 2. Okay. Now if I want to plot this vector field, जो given vector field V है जिसको मैं plot करूँ, तो I would see something like this. This is my xy plane and I would see something like this. And it will go on. So now you say curl is constant. So whether it would have, what is this? This is the measure of the rotation. So if I put a twig here, I will see that it will be rotated. This vector field will push it in this direction, this vector field will push in this direction. If I put the twig here, again it would be rotated. So it means this field, although it has got a constant curl, but still it has got rotation. Okay. But what if I make this positive? I make this positive, then what is the value of the curl? 0. Now what does that mean? So let us try to plot. This was for the case when my V was minus yi plus xj, but when I change the sign, my V is equal to yi plus xj, I get something like this. It goes like this. So if you put your twig here, it will be pushed out. If you put your twig here, it will be pushed out. There is no curl. If you put your twig here, it will be pushed out. No rotation at all. So this means such vector fields are called irrotational vector fields. Such vector fields for which the curl is 0 are called irrotational vector fields. Okay? Vector fields for which curl is 0, it is called an irrotational vector field. So these two concepts of divergence, curl and also gradient are very important. Why? Because they tell us that how a given field would change in any possible in perpendicular direction or along the direction of the given vector field. Okay? Divergence gives you, gradient gives you the change along, or it gives you that what should be the direction along which a particular function will change the fastest. in which direction the change would be rapid. Okay, so आप जब gradient calculate करते हैं of any scalar field, what you get, the slope tells us the direction of maximum change of a given scalar field. Okay, so it means these curl, gradient and divergence are important, and we have to understand that what is the physical significance, what actually when I have a vector field, say electric field or a magnetic field, then when I take curl, what actually is going to happen? You should be able to perceive, you should be able to form a mental picture that when I take curl of a given electric field or a magnetic field, and if a charge is placed in that electric field, then how that charge is going to behave, what kind of force it is going to see. Whether it's a rotational force, whether it's a torque or a force, what would be the force? And these forces or these causal effects are going to govern the propagation equation, electromagnetic wave equations in the effect of electric and magnetic field. Okay. So, it is very important that you understand the concept of divergence and curl well. So, if you have any confusion, you may please ask now, because in the next lecture we will calculate. Next lecture will be more of mathematical lecture, where we will convert this curl and divergence into spherical and cylindrical coordinates. Okay, and then we will move on to your course, that is on Maxwell's equations and electrodynamics. So, if you have any doubt or questions, you please ask me now. Okay, she wants to ask what would be the picture when divergence is 0. Okay, that's a good question. I will explain you. So, let me take the example that I had given and then we will move forward. Okay. So, she asked me that what would be, how the vector field would look like, isn't it? How the vector field would look like when the divergence is 0. Okay. So, let us take the example that we had, that V is equal to say half xi. Okay. And we said that this is equal to x and y, and this was varying like this. Now, I said that if I draw an arbitrary surface here, then I see that amount of flux or amount of liquid entering in is less than the amount of liquid that is coming out. But on the other hand, if I had a field phi I, then for this field divergence is 0. I say this is V2, this is V1. So, divergence of V2 is equal to 0, and if I plot this field, V2, then I get something like this. It's always 5, I go anywhere, it is 5. So, if I draw an arbitrary surface, whatever is going in is coming out. So, the net storage, neither the density is increasing here nor decreasing. So, the curl or so the divergence of such field is 0. So, this is the vector field notation or pictorial representation of a given constant field. Okay. Any other question, please? Any other question? No question. So, okay, then we end the lecture here today, and in the next lecture we will go on to converting these coordinates, these given curl and divergence and gradient, into spherical and cylindrical coordinate system.